Welcome to part 2 of the AICE Math derivative review. Today we're going to be going over the chain rule as well as other derivatives that you should know for the AICE exam, like e to the x, natural log of x, and your trigonometric derivatives. Other than that, I don't really think there are any other derivatives you should know of in particular, but today we're going to be starting the chain rule. So what is the chain rule? Basically, we know how to take the derivative of x to some power. That's our power rule, okay? But what if we have x plus 2 to some power? Do we just give up? I wish, but if we have a function inside of another function, so you could think of like an f of x as x plus 2, but then you're taking f of x and then you're squaring it, which is x plus 2 squared, so that's like another function on your function. So like think of x plus 2 as your f of x, right? And then your g of x, I'm gonna say your g of x is x squared, okay? This is like basic function stuff, basically. So g of f of x would be taking f of x and plugging it into here. That's all it is. So you're taking g of x plus 2, and g is just the squaring operator, so this is just going to be equal to x plus 2 squared. Why am I talking about this? Well, this is the main idea I want to emphasize. We have a function inside of another function. When we have x squared, that's its own function. But whenever we have x plus 2 squared, that's a function inside of another function. And it is confusing, but we can work around that, okay? There are many ways to teach the chain rule and how to do it. I'm going to go the more slow way, because I think it's the best way to be able to understand it. So if you already understand the chain rule, this is probably going to just be a little review for you, okay? So we're going to set a variable u, okay? We're going to set u equal to x plus 2. Why x plus 2? Because that's our inside function. Again, this is our f of x function, right? And so our g of x, we just plug in g of u, so it's going to be g of x plus 2, and we take, so then x plus 2 squared, therefore, x plus 2 squared becomes just u squared. So all we're doing now is just substituting variables in, and so then we have u squared. That's all we have. But, again, here, this is our chain rule. This is not u times v, this is u as a function of v. So again, v is g of x, so this is f of g of x. This is a function inside of another function. This is confusing, but we take the derivative of our outside function with respect to our inner function, and then multiply it by the derivative of the inner function. It's crazy, I know, but it's really not hard once you apply it. All we're doing here is we're taking our inside function, and so we're treating our inside function as its own variable, and then we're just multiplying it by the derivative of this. So I'll explain it through this example. So just do the normal power rule here. This becomes, I need to familiarize you with this notation. This is our differential operator. It's whenever you take a derivative. That's what it is. So d dx of u squared, it's pronounced d dx of u squared is equal to 2u. But remember, we need to add the derivative of v at the end. V is our inner function, which is x plus 2, so I'm going to multiply it by, well, okay, in this case it's u. I'm using u here and u's there too. The reason why I'm using u and v here is because that's what they use on the sheet for the AICE Math. I don't want to confuse you, but u is commonly used as a variable in calculus, so just disregard that for now. I could actually just make it less confusing by using a different variable. Let's use t. So let me just do that so it's not confusing. 2t, okay? But now we need to take t prime. So 2t times t prime. Well, what is t prime? Well, all it is going to be the derivative of the inside function. So this is simply equal to 2t. Well, we can't keep t actually. We have to have our answer in terms of x. So 2t, this is just going to be 2 times x plus 2, because you don't want to forget that, times the derivative of the inside, which is just 1, because derivative of x plus 2, this becomes 0, this becomes 1, 1x turns into 1, so this is your answer. That took a lot of explaining, but hopefully we can do it better here. And I know I'm using Greek letters. This is alpha and oh no, phi. That's phi. Yeah. Okay. So this again, we treat this as our, again, we'll say like r. This is our r. Okay. So this is just so ddx of, actually ddr in this case, we're taking the derivative with respect to r, of r to the 6th is simply equal to 6r to the 5th. But now we are multiplying it by r prime. Okay, so again, let's just resubstitute this back in. So this is 6 times 2x squared plus 3x plus 4 times the derivative of the inside. This is just 4x plus 3. Constant goes away. And once you understand the chain rule, you don't have to do the substitution. You can just see it like, okay, just move this in front and then just take the derivative, multiply it down here. That's it. I'm going to do a few more problems that involve multiple different functions, but that is the main idea of the chain rule. Alright, so here we have multiple rules at once. Here we have an example of the quotient rule with the chain rule, so we can actually just like get rid of this, put parentheses around our function, and say this is 1/2, right? Because that's all a square root is. There are different ways you can do this. You could do this to the 1/2 divided by this to the 1/2 and then do the chain rule inside. But what we're going to do is we're going to take the entire function and have the chain rule. So again, it looks very difficult, but if you take this as like your t, this is going to be 1/2 times your entire function. Just write it out. Write it out as you normally would here. And then normal derivative, just take to the negative 1/2 power. And then you're going to now do the quotient rule to do this inside here. So again, it's right here. 2x plus 3 times the derivative of the top function, which is 1 minus x plus 5 times the derivative of the bottom function, which is just 2. And then we're going to divide by 2x plus 3 squared. I think I already used this problem, but whatever. And that's it. That's our answer. That is our f prime of x. And yes, I went back to f and g. So g of x. So g prime of x. So how can we approach this? Again, we can approach this in different ways. We have this negative 3 power, so we could divide. But I want to use the product rule because the product rule is way less confusing and it's just more straightforward to use. I always prefer using the product rule when I can. So we have the first function, which is x plus 6, times the derivative of the second function, which is this entire thing. So we need to use the chain rule to figure out this derivative. So then basically treat this as a variable. This is going to be negative 3. Again, we're multiplying it, so don't add it, times 4x cubed plus 6 over x. Actually, let me just do 6x to the negative 1. I prefer that personally. 6x to the negative 1 times, this is actually just going to the negative 4 power because we're subtracting 1. And then, remember, don't forget, you have to multiply by the inside derivative, which is going to be 12x squared plus, again, this is 6x to the negative 1. So you're just going to do, this is actually a minus 6x to the negative 2. You're not done, because that's just the first part of the product rule. You're going to add it to this function, just normally without any derivatives, plus 6x to the negative 1, all to the negative 3 power. That's your entire function. And then times the derivative of that, which is just 1. And that's it. It looks a lot, and you probably got confused whenever I did this, but remember, this is just your this function, your u, and your v is this entire thing, this entire line right there. Chain rule is here. Basically, it's all chain rule. Basically, you take your function here, and it's this inner function, do the normal like power rule, and then derivative of the inside function, which is basically that in there. So that's your g prime of x. Alright, so now we added a few more derivatives. Basically, this is it. This is the end of it. We have e, natural log, and our 3 major trigonometric functions. Looks alike a lot, but remember, these are all on your table. You can easily just look at them. Okay, you're allowed to see these. Okay, we have 4 functions here, and we're just going to use this. And yes, we will use the chain rule. So a of x is equal to e to the 5x. So a prime of x is going to be, so if this is actually extremely beautiful, how the derivative of e to the x is itself. That is like it's hard to appreciate it if you aren't really if you don't really know much about like derivatives and how they work, but it's amazing. Anyway, so we're gonna use the chain rule. Okay, so e to the 5x. So again, 5x is like our u. So this is just simply e to the 5x times derivative of 5x, which is 5. 5e to the 5x. That's it. B prime of x is simply equal to, so 6, don't worry about the 6 for now. You can just put the 6 in the front. This is going to be e, because the derivative of e to whatever is e to the whatever. So e to the 3x squared, and then we're going to multiply by this derivative, which is 6x. And then you can do whatever you want. That's 36e to the 3x squared times x. Pretty easy, actually. C of x. So c prime of x. So c of x is natural log of 5x. You could separate it, ln of 5 plus ln x, and that's easy, but let's use the chain. Why not? So, okay. Basically, this is 1 over 5x, because the natural log of something is 1 over that something, but since we're doing the chain rule, we have to take the derivative of the inside, which is 5. And 5 divided by 5x is just 1 over x. Did I do that right? Yeah. That's weird. Okay. So d prime of x, so our derivative is actually interesting because look, ln squared, what's ln squared? Well, this is basically like sine squared, cosine squared, but just for the natural log. Basically, you're taking ln, you're taking the natural log of this and squaring it. What does this mean? This means that you have this as your first function. This is f1. Let me actually erase this because I'm going to need to use this space. And then you have this function, which is f2, your natural log, and you have your natural log squared function, which is your third function. So what do? Well, you have to use the chain rule twice. And yes, that does seem like a lot, but you will probably have to do that at some point. So, how do we do this? Well, you can think of this as like your inner function, and this is your outer function. Just disregard the 12x squared for now. So d prime of x is just equal to 2 times natural log of 12x squared to the first power, so you don't have to worry about that. But then you're going to multiply by the derivative of the inside, which is just 1 over 12x squared. But then you have to multiply by the derivative of this. Wait, hold on. Let me just make sure I'm doing it right, because it is confusing. Even if you know this stuff, it is still like, you have to make sure you're doing it right. So you take this, multiply it by that, and then you take, you multiply by this derivative, which includes, so you multiply by that, so then this, I'm just going to write it up here. Derivative of that is 24x. And that's your entire derivative. It is a lot, because, but like, I mean, this is not that bad, like, compared to other, like, chain rules inside of chain rules, but that is your chain rule, that is E, and that's natural log. Alright, so now the trigonometric functions, that's these three. We're just going to do these two for now. So sine of 3x, again, chain rule here, so derivative of sine x is cosine x. I'll probably eventually do a proof for that, but so a prime of x is just going to be, so sine is going to turn into cosine of 3x, and then we're going to multiply by the derivative of that, which is 3. So 3 cosine 3x, that's it. B prime of x, so if cosine, so again, you can just think about this as cosine x squared. So if cosine turns into negative sine, again, chain rule here, so 2 times negative sine x, okay, and then again to the first power, so we don't have to worry about that, but then we're going to multiply by the inside, the inner derivative. Wait, no. I'm a whole step ahead of myself. This is just 2 cosine x, right? Okay, and then we're going to multiply by negative sine x. There we go. So that's just negative 2 sine x times cosine x. Okay, so let's do some other interesting ones. Basically, you might be asked about the derivative of secant x or cosecant x, so let's just do those. So ddx denotes the derivative of cosecant x, and then the derivative of secant x, okay? Remember, cosecant x, this is just the derivative of 1 over sine x, or the derivative of sine x to the negative 1, not sine negative 1 of x. It's not the inverse, it's not the arc sine. So we can use the chain rule. So this is just equal to negative sine x to the negative 2 power times inside the inner derivative sine x is just cosine x, which we can actually simplify because this is just negative cosine x over sine x squared. That's just equal to cosine over sine is cotangent. Actually, this is a negative cotangent, so it equals negative cotangent x divided by sine x. And that is your derivative of cosecant. How about secant? Again, this is just, I'm going to do it down here. Derivative of cosecant x to the negative 1. Okay, just doing the same process here. And that's just going to be equal to negative not negative cosecant, this is just cosine here. Negative cosine x to the negative 2 times the derivative of cosine, which is negative sine. This negative and that negative cancel, and we're just left with sine x over cosine x squared, and that is simply equal to sine over cosine is just tangent of x divided by cosine of x, and that is your derivative for secant. So yeah. Alright, so now we're going to work with tangent. So the derivative of tangent x is secant squared x. You can find that by doing the quotient rule of sine and cosine. So this is simply just equal to d dx of 1 over tan x, and that's just equal to d dx of tan x to the negative 1, and basically, so that's going to be negative tan x to the negative 2 times derivative of tangent of x is secant squared of x, and this is equal to negative secant squared over tangent squared x. And so since secant is 1 over cosine, so this is just equal to 1 over cosine squared x times 1 over tangent squared is just cotangent squared, which is cosine squared x over sine squared x. And these actually cancel out really nice to leave us with 1 over sine squared x. That is equal to cosecant squared x. Alright, so f of x is equal to this crazy function. Again, tangent squared, we can just worry about having it like that. Again, function inside of a function inside of a function, okay? A little confusing, but it's okay. We can get through it together. Whoa. F prime of x is equal to, okay, so again, treat this as its own function. So we have 2 tan 10x cubed plus 1 over x squared. Let me just write that as x to the negative 2. Okay, times the derivative of the inside, which is secant squared, so times secant squared of this entire function, so it's 10x cubed plus x to the negative 2, okay. So this, okay, so remember, so this is just this times the inside, times the derivative of the outside, times the derivative of the inside, and so here we have to use the power rule as well, or the chain rule as well, so we have the derivative there times, I'm just going to do a times, derivative of the inside, which is 30x plus, and then again we have this x to the negative 2, 30x squared, plus, this is actually minus 2x to the negative 3. And so then I'm just going to do that in parentheses there. That's our entire derivative. So yeah, that was a lot. That was chain rule, basically the rest of your derivatives, and yeah. Thanks for watching, and I hope you will stick around for part 3. That's hopefully going to be a little shorter.